Yes, welcome students. I welcome you to one more video lecture on maths. This time I want to share with you the simple proof of this 0 factorial is equal to 1 factorial is always 1. You have whether 0 factorial, it is 1. You have 1 factorial, it is 1. You see, if we go to the history of this 0 factorial that we use equal to 1, previously, without proof, we used it equal to 1. That is known as conventional proof. That is, in fundamental problems in physics and maths, if you do not use 0 factorial equal to 1, then the basic laws fail. It is one. This is known as conventional proof. Conventionally, it is proved that 0 factorial is 1. But when we go ahead, we have different procedures, different theorems, different this dealings in mathematics. Then with the help of those results also, we can prove that 0 factorial is 1. You see, this time I am giving you the simple proof. This is actually this proof I share for this higher secondary school students who will understand this proof very easily. It is an accepted proof that 0 factorial or 1 factorial is 1. But you have other proof, fundamental. There are several proofs for this, several proofs, not only 2 or 3, several proofs. Other proof we give to this, that is known as gamma function. Gamma function. It is this gamma function, you know, we have special types of functions. One of them is gamma function, beta function, special integrals, you may say. We prove this with the help of gamma function and with pi function, using pi function. I will also share the proof of this 0 factorial 1 with the help of this later on. But students of lower class cannot understand this until and unless they have the concept of this special integrals. One of them is gamma function, then beta function, and with the help of this we have pi function. We can also prove the same result with the help of beta function and this pi function. This time I want to share this proof, very simple. It will be accepted by everyone. This can be the proof for this, that 0 factorial, 1 factorial is always 1. I will use the concept of this definition of, by definition of factorial notation. Factorial notations, you know, we have for every n belonging to set of natural numbers. Okay, we define this factorial natural numbers. Later on I will give you, we have also the factorial notation for negative number, that I will share some problems with you. This is the, when we have n a natural number, how we define n factorial. We write there by definition, this is n into n minus 1. This is product here, into, then into n minus 2 into n minus 3. That is, it goes decreasing. Last you have last but 1, 2 into 1. 2 into 1. Okay, I have used a dot as into, I will use here. It is 2 into 1. 2 into 1. 2 into 1, last one. Or you can write it in reverse way also, or you can write this way also, and factorial you can write the product of first n natural numbers. That way also you can write 1 into 2 into 3 into 4 into dash dash so on to n, then last but 1, n minus 1, so on. This way also you can write the product of this, the factorial notation we define in this way also. This is the fundamental, this definition of the factorial notation. You see, by this, if we have, say, 6 factorial, I can write 6 into this 5 into 4 into 3 into 2 into 1. Sometimes I can write this. If you see what is the product, 5 into 4 into 3 into 2 into 1. This you can write 6 into this 5 factorial. Is it? That means you can write this as 6 into this is 6 minus 1 factorial. One and the same thing. That is, you can put a break. Suppose you have 7 factorial. You can write 7 into 7 minus 1 factorial. Is it? Because 7, when you write 7 minus 1, 6 factorial. After this, you have 6 into 5 into 3 into 2 into 1. Or you can put break in this way. You write 7 factorial as 7 into 6 into, then here 5 factorial. You put sometimes break as per your requirement. Add 5 factorial, add 4 factorial, whatever you like. That means you can write this is 7 into 6 into 7 minus 2 factorial. Is it? 7 minus 2 factorial, because it is now 5 factorial. After 5 you have 4, you have 5 into 4 into 3 into 1. This is how you write, you express that factorial notation. Means if we have this n factorial, I can write this n factorial as also n into n minus 1 factorial. No problem. Or I can write this factorial n factorial as n into n minus 1 into n minus 2 factorial. Where I need to apply the break, I use the break, I stop it at n minus 2. That means n minus 2, I have after n minus 2 as n minus 2, n minus 3, n minus 4, n minus 5. This is how we use factorial notation by this definition. Now from this we will now deduce how this 0 factorial and 1 factorial is 1. This is your concept from class 11th standard, and nowadays we have this also in 10th standard. In this American curriculum, this syllabus, there you have this factorial notation from. So that means you can write n factorial is the product of first n natural numbers, or this way we can write the same as in this way also, n factorial n into n minus 1, or whatever you like, n into n minus 1, n minus 2, or n into n minus 1, n minus 2, then n minus 3 factorial. Okay, so this is how we write factorial notation, where we define it. With the help of this, we can prove within 2 steps. You just see. Yes, let us now have its proof. As we have seen just that we can write this n factorial as, we can write this as n into n minus 1 factorial. Name this first. This I have explained you how we can do it. Let me put, I will first derive the value of 1 factorial. If we put here n is equal to 2 here in first, what you get? It is 2 factorial is equal to 2 into 2 minus 1 factorial. This you can write 2 into 1. It is 2, that is 1 factorial. This 2 and 2 goes. 2 is equal to 2 into 1 factorial. That gives 1 is equal to 1 factorial. So I have proved first thing that 1 factorial is 1. Because when you write n factorial is the product of first n natural numbers, there will be the question can arise. How can write we 1 factorial? What is 1? 1 into what is this? When we write 2 factorial, 2 into 1, 3 factorial, 3 into 2 into 1, 6 factorial as 6 into 5 into 2. So question arises, what is 1 factorial? How we write it? 1 into what? So you have come to know by this that our formula is for 1 factorial directly 1. 1 factorial is 1. Remember this. Next I will put in first, put n is equal to now 1 in first. This I will name for the time being second, what I have proved here. Second. I put n is equal to 1 in first. In first equation, what I get? 1 factorial is equal to 1 into 1 minus 1 factorial. Okay, 1 factorial. There is no question now. What is 1 factorial? We have proved it. We have derived first the value of 1 factorial. So it is 1 is equal to 1 into, this is your 0, factorial. 1 and 1 goes, that is 0 is equal to 1 factorial. So this is the proof how, 0 factorial is 1. This is 0 factorial. 0 factorial is equal to 1. This result we have proved that 0 factorial is 1 when we use the value 1 factorial is 1, and we have also derived how 1 factorial is 1. Then we have derived 0 factorial is 1. Yes, previously this was conventionally used that 0 factorial is 1 in fundamental results in long before. But when we have the new concepts in mathematics, like we have this gamma function, special integrals, with the help of that we have also the proof, and this and factorial notation definition, and with the help of this we have that 0. It is considered to be the simple proof, simple one, and everybody for lower classes this is sufficient how we use 0 factorial 1 or 1 factorial 1. And sometimes I will discuss with you the gamma function and beta function, pi function, and from there I will also give you the definition of this how 0 factorial is 1. Thank you very much. I hope you have understood this simple proof. I request you, remember one advice: you read mathematics, because it is only mathematics that activates your rational brain. Thank you very much.